Question 13, recurring decimals. So the method, let A equal 0.248888, and then I've got to multiply this by something so that the repeating decimal can be subtracted away from each other. This one's fairly straightforward. I can just multiply by 10 and I will get 2.48888. When I subtract now, all of these 8s will cancel. Be careful because this 8 doesn't. And then when I subtract, I'm left with 9A equals 2.48 minus 0.24. So the takeaway I'm doing is as follows. So I end up with 9A is equal to 2.24, and then divide to get A on its own, 2.24 divided by 9. And then I can't have a mix of decimals and fractions, so I need to times by 100. So I end up with 224 divided by 900. It doesn't ask me to simplify the fraction, so I can leave it as that. Part B, indice rules. So the first rule you need to recognize is that the minus sign means 1 over this. Now with a fraction, the 1 over is effectively the inverse, so I can just flip the fraction upside down. I keep the indice there, but I've now lost the negative sign. Now with 2/3, the number on the top represents the power and the number on the bottom represents the root. So this is the cube root of 27 squared. You have two options. You can either do 27 squared first, then cube root it, or you can cube root 27 and then square your answer. Always try and do the root first because it makes your number smaller. So the cube root of 27 is 3. So this ends up as 3 squared, and 3 squared is 9.